Alright, in this video we'll be taking a look at Unit 2A entitled Understand, Solve, and Explain. So we'll be looking at solving problems, and one of the big ideas that we're going to be looking at in problems we're going to be solving here is what's called unit analysis. Sometimes it's also referred to as dimensional analysis, and we'll get into that idea of what we mean by unit analysis here momentarily. But as we look at this idea of understand, solve, and explain, it's a three-step problem solving concept, and I'm not going to review all of this, and it's not something you need to memorize by any means. It gives you a platform or some kind of structure to help you in solving and working through problems mathematically. And so just a couple things that that I will be pointing out. When you're solving problems, what information is given, and also should mention up here above, what exactly are you supposed to determine? So identifying exactly what is the question I'm being asked, especially when you're given a big paragraph of information or whatever it may be. What exactly are you supposed to figure out? What information are you given? And then also one other thing I'm going to point out and understand is, what should a solution look like? If we're talking in miles per hour or something like that, and you get an answer that's 36,000 miles per hour, should a speed of a car or a boat be in the 36,000 miles per hour range? That's more of a space shuttle type speed when they're slingshotting off of a planet or off of the moon or something like that. So, what should your solution look like? What seems reasonable? Over in the solve, just a couple of things that I want to point out here is, obviously obtain or identify any information that you need. And another thing that's really helpful is to organize your work. Okay, so being organized and having a process, and that could be different from person to person. Double checking your work, that is always, especially on an exam, and if you have a job, it's always good to double check and make sure you did things right. And so those are a couple things in solve. And then in explain, be sure that your results make sense, as I mentioned before. Kind of going back to the, does a car travel at 36,000 miles per hour? No. So make sure that your answer makes sense, and write out your solution clearly, concisely, so that people can understand what you're trying to say. So that's the idea of understand, solve, and explain. Again, there's more in there that I haven't highlighted, but there is a little bit of process, and when you're dealing with application problems, story problems, it takes time, and these are things that are helpful in developing those skills in order to accomplish some of these problems. So now we're going to step down, and this idea of understand, solve, and explain, that's what we're going to be doing kind of in the background today. But again, we're going to really be focusing in on this idea of units analysis. Okay, but first, this concept here of a unit. Okay, the units of a quantity describe what the quantity measures or counts. So, some units might be miles. So you might have like miles, you might have gallons, you might have dollars, you might have time, so you could be like seconds or minutes. So that's what we mean by units. Okay, well, what are the units we're dealing with? And so then when we mention unit analysis, is the process of working with units to help solve problems. And we're going to look at one kind of right out the gate that is going to involve quite a bit of work, but just something for us to think about, because it's interesting. We hear this term. So in example 1 here, we hear this term light years. This star is so many light years away, and what does that mean when they're talking light years? And so the first thing we're going to look at when we're trying to understand the question is, well, when they're talking light years, they're talking about how far away something is. So they're talking about this idea of a distance. So we can get an idea of understanding the problem when we understand a light year is a distance. And then we need to understand something about distance. Well, the way you find distance is you take your speed, which you're traveling, and multiply it by the amount of time traveled. And another way this is written is that distance equals rate times time. That's another way you'll see this written commonly. But speed times time, that's how we measure distance. I mean, if you think about it, when you're in a car, if you're going 75 miles per hour for 2 hours, then you will have traveled 150 miles, because you go 75 miles the first hour, 75 miles the second hour, so you multiply your speed by your time to get your distance. Okay, and so now that we understand a light year is a distance, okay, so then we need to say, well, then if I look at a single, so 1 light year, that's going to be equal to, well, how fast, what speed are we going at? Well, light travels at this concept that we call the speed of light. And then we're going to multiply that by 1 year. And that's what is meant by a light year. Okay, so traveling at the speed of light for a single year. So that'll be 1 light year. If it's 25 light years, then we would say the speed of light times 25 years. So now we have an understanding of what a light year is, and now we need to kind of solve. We need to go about how do we solve this thing here. Well, the speed of light, and we'll give you an approximation here. Actually, this is a pretty solid number here. So it's 300,000 kilometers per second. So now we're using units. Kilometers is a unit, seconds is a unit. So we're using that. So that's our speed of light. We need to times that by 1 year. Okay. And we want to again figure out how many, and this is, we're going to find out this in kilometers and later in miles, but 300,000 kilometers per second times year. Now notice this is where unit analysis comes in. Notice that we're dealing with seconds and years. Okay, it's really hard to compare seconds and years together, so we need to get on the same playing field. So we need to either determine how many seconds are in a year or how many years are in a second. And I would recommend going how many seconds are in a year so you don't get a really small decimal. And so this concept that I'm showing you here, and I know this is brand new for some of you, but this is just the general process, is we take the 300,000 kilometers per second and we're going to times that by 1 year. And then we need to start breaking down the years into seconds. So we need to figure out how many seconds are in a year. Now, yes, you could Google this thing, or we can use this idea of unit analysis that we're going to be looking at today to break this down. And the way we do is we say, okay, there are 365 days in 1 year. So we're multiplying by what are called unit fractions, because 365 days in 1 year, those are equivalent. So that's like multiplying by 1. And then, so that takes us from years to days. And then we can go from days to hours. So there are 24 hours for every 1 day. And then we can go from hours down into So we can go down from hours into minutes. So there are 60 minutes for every 1 hour. Again, all of these are equivalent to 1. So when we times it, we're not changing the problem. And then there are 60 seconds for every 1 minute. And we're finally down to seconds. So all of this, again, all of these fractions right here, so every one of these fractions are equivalent to multiplying by 1. So this is like times by 1. Because 365 days is 1 year. 24 hours is 1 day. So we're really just multiplying by 1. But notice now what happens is technically this would be 1 year over 1 as a fraction. So the years will cancel. Then the days cancel, then the hours cancel, then the minutes cancel, and we are left with seconds. So now we have 300,000 kilometers per second times, and you're going to multiply out, so I'll highlight these numbers, 1 times 365 times 24 times 60 times 60 in the numerator. And then the denominator is 1 times 1 times 1 times 1 times 1, so that's just 1. So in the numerator, you're going to take 1 times 365 times 24 times 60, which is 315360000. And again, the unit there is seconds, and that's in the numerator of our fraction. So that's how many seconds there are in a year. So now we have our speed, which is 300,000 kilometers per second, and we've got our time, which is huge, so that is going to be in the millions there, 31,536,000 seconds. And notice that this seconds and this seconds are going to cancel because one's in the numerator, one's in the denominator, so we're left with just kilometers. And this is approximately, so this is going to be rounded, but this is approximately 9,460,000,000,000 kilometers. Oof. So there should be 1, 2, 3, 4, 5, 6, 7. Oops, 3, 6. I should have 10 zeros in there. So sorry, my kilometers kind of messed that up there. Okay. So 9,460,000,000,000 kilometers is 1 light year. That's the distance of 1 light year. So this idea of taking 1 light year is the speed of light times a year, converting a year into seconds. This is what we call unit analysis, and unit conversions is sometimes, there's a lot of different names that are used for this. But again, so now we've solved. Does that make sense? Yeah, because when you think of traveling the speed of light for that period of time for an entire year, you should put some significant distance between you and your starting point. So we'll pick this up in part 2.